This is an audio-visual presentation on relations and functions. Relations refers to the connection between the elements of one set with the elements of another set. Now let's look at the illustration. The elements of the set X are 1, 2, 3, 4, and 5. And the element of the set Y are 2, 4, 6, 8, and 10. Now when we consider the relation, we can see that 1 is related to 2. That is 1 being an element of X is related to 2 being an element of Y. 2 is also related to 4. 3 is related to 6. 4 is related to 8. And 5 is also related to 10. So we can see that the element of the set X are all related to the element of the set Y. The element of the set X are related to the element of the set Y. So we see there's a relation between the set X and the set Y. The domain of a relation is made up of the elements in the set X. The set Y is called the codomain, and the set of all images in Y is called the range of the relation. The domain of a relation is made up of elements in the set X, and the set Y is called the codomain. The set of all images in Y is called the range of the relation. Now, considering the relation as shown, X is related to Y. So considering the relation, we can see that 1 is related to 2. 2 is related to 4. 3 is related to 6. 4 is related to 8. And 5 is also related to 10. So we can see that the element of X are related to the element of Y. So there's a relation between X and Y. Now, we said that the element of the set X is called the domain. And therefore the domain is 1, 2, 3, 4, 5. Since they are the elements of the set X. So the element of the set X is called the domain. Now, the element of the set Y is what we call the codomain. So the codomain equals 2, 4, 6, 8, 10. That is the codomain is 2, 4, 6, 8, 10. Now the range is equal to 2, 4, 6, 8, 10. The range are the images in Y. Now, when we look at the relation between the element of the set X and the element of the set Y, we can say that the image of 1 is 2. The image of 2 is 4. The image of 3 is 6. And the image of 4 is 8. And the image of 5 is 10. So the images are 2, 4, 6, 8, and 10. So the range is equal to 2, 4, 6, 8, and 10. Take note that the element of the set X is what we call the domain. The element of the set Y is what we call the codomain. And the images of the set Y is what we call the range. Now, types of relation. The first type of relation is one-to-one relation. Now, when we look at the diagram, there is a relation between X and Y, because 1 in X is related to 2 in Y. 2 in X is related to 4 in Y. 3 in X is related to 6 in Y. 4 in X is related to 8 in Y. And 5 in X is related to 10 in Y. So there is a relation between X and Y. However, we can see that each element in X is related to one and only one element in Y. That is, 1 is related to only 2. 2 is also related to only 4. 3 is also related to 6. 4 is related to 8. And 5 is related to only 10. And so we say this is a one-to-one relation, because each element in X is related to one and only one element in Y. So we say it's a one-to-one relation. Now we have the many-to-one relation. The element of the set X is 1, 2, 3, 4, 5. And the element of the set Y is 2, 4, 6, 8, 10. Now there is a relation between the element of X and the element of Y. From the relation, we can see that 1 is related to 2, 2 is related to 4, and 3 is also related to 4. That is, 2 and 3 are all related to the element 4 in Y. 4 is related to 8, and 5 is related to 10. We say this relation is many-to-one relation because at least 2 elements in X is related to the same element in Y. So a relation is said to be many-to-one relation if at least 2 elements in X is related to the same image in Y. When it happens like that, then we say the relation is many-to-one relation. That is, 2 elements or more, at least 2 elements in X is related to the same image in Y. So we have many-to-one. Now we also have one-to-many relation. Now when we consider the relation, there is a relation between X and Y. 1 is related to 2, and 1 is also related to 4. That is, the element 1 in X is related to 2 elements in Y. So we have one-to-many. Even though 3 is related to 6 only, 4 is also related to 8 only, and 5 is also related to 10 only. Because one element in X is relating to 2 different elements in Y, we say this is a one-to-many relation. So a relation is said to be a one-to-many relation if at least if one element in X is related to more than one element in Y, then we say it's a one-to-many relation. It's a one-to-many relation. That is, an element in X is related to 2 elements in Y, either 2 or more. So 1 is related to 2 and 4, and that is why this is called a one-to-many relation. Now we have a many-to-many relation. Now with a many-to-many relation, when we consider the relation between X and Y as shown, we can see that 1 is related to 2 and 4 in Y, and that is one-to-many relation. We can also see that 2, 3, and 4 are all related to 6 in Y, and that is many-to-one because you have many elements in X relating to one element in Y. So we say we have many-to-one. Then when we consider the element 1 in X, the element 1 is related to 2 and 4, and that one is one-to-many. So when one-to-many and many-to-one are combined in one relation, then we call it many-to-many relation. Now let's consider the relation between X and Y. 1 is related to 2, 2 is related to 4, 3 is related to 6, and 4 is also related to 6, and 5 is related to 10. Now we said that the domain are the elements of the set X. So the domain is 1, 2, 3, 4, 5. So the domain is equal to the element of the set X. That is 1, 2, 3, 4, 5. Now we also said that the codomain is the set of the element Y. The codomain is the set of the element Y. And the elements in Y are 2, 4, 6, 8, 10. So the codomain equals 2, 4, 6, 8, 10. And the range are the images. Now, when we look at the set Y, the image of 1 is 2. The image of 2 is 4. The image of 3 and 4 is 6. And the image of 5 is 10. 8 is not an image, and therefore it is not part of the set of the range. So the range is the set of elements 2, 4, 6, and 10. Since 2, 4, 6, and 10 are the images. So take note. The domain is the set of the elements you have in X. The codomain is the set of the elements you have in Y, but the range are the images alone. So because 2, 4, 6, and 10 are the images of the element you have in X, it implies that the range is equal to 2, 4, 6, 10. Now we look at mapping. A mapping is a relation between two sets of objects, in which each object in the first set goes to one and only one object in the second set. Now, rule of the mapping. The rule of the mapping is a relation connecting the two sets. The rule of the mapping is the relation connecting the two sets. Now we have the linear mapping. A mapping is said to be linear if the difference between the consecutive images is constant. A mapping is said to be linear if the difference between consecutive images is constant. Now let's consider the two sets. We have the set X, and the elements are 0, 1, 2, 3, 4. And we also have the set Y, and the elements are 2, 5, 8, 11, 14. Now, by means of an arrow diagram, the element of X can be related to the element of Y as shown. So we have 0 related to 2. 1 related to 5, 2 related to 8, 3 related to 11, and 4 related to 14. That is by means of an arrow diagram, we can map the element of X to the element of Y. That is 0 is mapped to 2, 1 is mapped to 5, 2 is mapped to 8, and 3 is mapped to 11, and also 4 is mapped to 14. Now, these are the elements of the set X, 0, 1, 2, 3, 4. And the element of the set Y are 2, 5, 8, 11, 14. Now, because the element of the set X are mapping to the element of the set Y, it means that the set Y are the images. So you have 2, 5, 8, 11, 14. Now, the difference between 2 and 5 is 3. The difference between 5 and 8 is 3. The difference between 8 and 11 is 3. And the difference between 11 and 14 is also 3. So because there is a common difference between consecutive images, it means that this mapping is a linear mapping. So a mapping is said to be linear if the difference between the consecutive images is constant. So we can see that the difference is constant, that is 3 throughout. Now the rule for linear mapping is given by y equals b plus d over k into bracket x minus a, where b is the first term of the set y. So in this case, b will be equal to 2. D is the common difference. That's the difference between the first term and the second term. And the difference is 3. Or the second term and the third term. The difference is still 3. Or the third term and the fourth term. Or the fourth term and the fifth term. The difference is 3 throughout. Now k is the difference between the x values. The difference. So you can see that the difference between 0 and 1 is 1. The difference between 1 and 2 is 1. The difference between 2 and 3 is 1. And the difference between 3 and 4 is also 1. So we have x minus a, where a is the first term of the set x. A is the first term of the set x. And so considering the element of the set x, the first term is 0. That means that a is equal to 0. So the rule for the linear mapping is y equals b plus d over k into bracket x minus a. Now, considering the two sets, the element of the set x are 0, 1, 2, 3, 4. And the element of the set y is 2, 5, 8, 11, 14. Now we said that the first term of the set x is equal to a. And considering the set x, the first term a equals 0. And that is why a is equal to 0. The first term of the set y equals b. And b is equal to 2. Now when we consider the set y, the first term is 2. And that is why b is equal to 2. The common difference between consecutive images in y is equal to 5 minus 2, and that is 3. Since y are the images, if you want the common difference, it is the second term minus the first term, or the third term minus the second term, or the fourth term minus the third term, or the fifth term minus the fourth term. That will give us the common difference. So 5 minus 2 is equal to 3. That means that the common difference is equal to 3. Now the common difference between the x values is the second x value minus the first x value, or the third minus the second, or the fourth minus the third, or the fifth minus the fourth. So the common difference between the x values equals 1 minus 0, and this is equal to 0. Now the rule for linear mapping, y equals b plus d over k into bracket x minus a. Now b is equal to 2, a is equal to 0, d is equal to 3, and k is equal to 1. That is 1 minus 0 is giving us 1. That means k is equal to 1. Now, by substitution, a give us 0, b give us 2, and k is equal to 1 minus 0, that is 1. D is the common difference between the consecutive images, that is 5 minus 2, or 8 minus 5, or 11 minus 8, and the answer is 3. Now, the rule for the linear mapping is given by y equals b plus d over k into bracket x minus a. Now, by substitution, we have y equals 2 plus 3 over 1 into bracket x minus 0. This is because b equals 2, d equals 3, k equals 1, and a equals 0. Now x minus 0 equals x. 3 divided by 1 equals 3. So 3 times x is giving us 3x. So we have y is equal to 2 plus 3x. This is now the rule for the given mapping. This is now the rule of the given mapping. Y equals 2 plus 3x. Now we look at the exponential mapping. A mapping is said to be exponential if there is a common ratio between consecutive images. A mapping is said to be exponential if there is a common ratio between consecutive images. So with the exponential mapping is the common ratio. Now let's consider the two sets. The set X, we have the element 0, 1, 2, 3, 4. And with the set Y, we have the element 3, 6, 12, 24, 48. By means of an arrow diagram, the element of the set X. By means of an arrow diagram, the element of the set X can be mapped to the element of the set Y, as shown below. So 0 maps to 3, 1 maps to 6, 2 maps to 12, 3 maps to 24, and 4 maps to 48. Now the rule for exponential mapping is given by y equals br exponent x minus a. This is the rule for exponential mapping, that is y equals br exponent x minus a, where b is the first term of the image. In this case, b will be equal to 3. A is the first term of the set X, and in this case, A will be equal to 0. R is the common ratio, and the common ratio is the second image divided by the first image, or the third image divided by the second image, or the fourth image divided by the third image, or the fifth image divided by the fourth image. That is how we find the common ratio. That is how we find the common ratio. Now we consider the two sets. X equals 0, 1, 2, 3, 4, and Y equals 3, 6, 12, 24, 48. Now we said that the first term of the set X is equal to A, and the first term equals 0. That means that A is equal to 0. The first term of the set Y equals B, and the set Y, the first term equals 3. That's why B is equal to 3. The common ratio between the consecutive images in Y is given by R, and that is the second image divided by the first. That is 6 divided by 3, which is equal to 12 divided by 6. And this is equal to 24 divided by 12, and it's equal to 48 divided by 24. And in all these cases, we have the common ratio R to be equal to 2, because 6 divided by 3 equals 2, 12 divided by 6 equals 2, 24 divided by 12 equals 2, and 48 divided by 24 is also equal to 2. Now, from the rule for exponential mapping, we have y equals br exponent x minus a. Now we have a to be equal to 0, b to be equal to 3, and the common ratio r equals 6 divided by 3, and this is equal to 2. So from the rule for exponential mapping, we have y is equal to br exponent x minus a, b equals 3, r equals 2, and a equals 0. So by substitution, we have 3 times 2 exponent x minus 0. Now x minus 0 equals x, and therefore we have y equals 3 times 2 exponent x. Now because of the exponent x, we can't multiply 3 by 2, and so we can't multiply 3 by 2 to get 6, and so y is equal to 3 times 2 exponent x. So y equals 3 times 2 exponent x is the rule of the exponential mapping that was given. Now we look at function. A function f is a relation between two sets, say x and y, in which each element in x is related to one and only one member of the set y. A function f is a relation between two sets, say x and y, in which each element in x is related to one and only one member of the set y. Now let's look at this question. By drawing an arrow diagram, determine whether or not the following relations are functions. I. F of x equals x squared for x equals 0, 1, 2. F of x equals 2x for x equals 2, 3, 4. II. G of x equals x squared for x equals 0, 1, 2. And g of x equals 3x for x equals 2, 3, 4. Now, let's consider the solution. Considering the function in I, f of x equals x squared for x equals 0, 1, 2, and f of x equals 2x for x equals 2, 3, 4. Now, let's consider f of x equals x squared for x equals 0, 1, 2. When x equals 0, 0 square will give us 0. So we have 0 mapped to 0. Now, when x equals 1, 1 square will give us 1. And that is why 1 is mapping to 1. When x equals 2, 2 square will give us 4. And that is why 2 is mapping to 4. Now, don't forget that we also have x equals 2 here. That is when f of x equals 2x. We have values of x from 2 to 4. So, considering f of x equals 2x for x equals 2, 3, 4, when x equals 2, 2 times 2 is equal to 4. So, 2 is still mapped to 4. It's the same thing. Now, when x is equal to 3, 2 times 3 is equal to 6. That is why 3 is mapping to 6. When x is equal to 4, 2 times 4 is equal to 8. And that is why 4 is also mapping to 8. So we can see that 0 is mapped to 0. 1 is mapped to 1. 2 is mapped to 4. 3 is mapped to 6. And 4 is also mapped to 8. Now f defines a function since each element of the domain maps onto one and only one element in the codomain. So we can see that each element in x is mapped to one and only one element in y. And that is why f is a function. So f of x is a function because each element in x is mapped to one and only one element in y, as shown. Now, considering the example in II, we have g of x equals x squared for x equals 0, 1, 2. Now, when x equals 0, 0 square is equal to 0. That is why 0 is being mapped to 0. Now, when x equals 1, 1 square equals 1. So we have 1 mapping to 1. When x equals 2, 2 square is equal to 4. So we have 2 mapping to 4. Now, considering g of x equals 3x for x equals 2, 3, 4. When x equals 2, 3 times 2 will give us 6. That means that 2 is also mapping to 6. When x equals 3, 3 times 3 is giving us 9. So we have 3 mapping to 9. When x equals 4, we have 3 times 4, and that is 12. That is why 4 is mapping to 12. So when we look at the mapping, we can see that 0 is mapped to 0. 1 is mapped to 1. The element 2 in x is mapped to 2 elements in y. That is 4 and 6. 3 maps to 9. And 4 maps to 12. Now, g does not define a function since an element that is 2 in the domain has 2 images in the codomain. Now, because the element 2 in the domain has 2 images in the codomain, it means that the function g is not a function. This means that g of x is not a function. G of x is not a function because the element 2 in x has 2 images in y, and therefore g of x is not a function. This is the end of our presentation on relations and function.